In lesson 11.8, we're going to talk about the general binomial expansion. So what we really do is look at Pascal's triangle in a different way, looking at each term of the triangle as a binomial coefficient. Binomial coefficient is in that notation you've seen before, n choose r, where n is still n factorial over n minus r times r factorial. So that's called a binomial coefficient. So using binomial coefficients, we can rewrite Pascal's triangle in the way that you see here, where the first term, there we go, is going to give you the row number. So this is row 0, and the bottom number gives you the position number, so position 0. So it's easier to remember. I mean, row 0, position 0, and then for these, it's row 1 is the top number, and then this is position 0, position 1. All of these are in row 2. The position goes 0, 1, 2. These are in row 3, position 0, 1, 2, 3. So the only thing you need to really remember is to start counting with 0. And so this way, we don't have to memorize Pascal's triangle or generate, adding the two terms above it every time, especially when we get down to, higher rows and higher powers. We don't have to think about generating the entire triangle. So, for example, let's say I was expanding like a plus b to the 15th, and I just wanted to know what the 11th term was. Now, instead of generating Pascal's triangle all the way down to the 15th row and then moving over to the 11th term, just knowing that I start counting at 0 makes this much easier. So the coefficient at that point would be in row 15, so 15 for the numerator, and then the 11th term, remembering that it starts counting at 0, would be at position 10. So that way I can jump straight to generating the coefficient much faster. Okay, so example 1, use binomial coefficients to expand. So we're going to do a plus b to the 6th. So instead of using Pascal's triangle to generate each of the coefficients, I am going to use Pascal's triangle but using binomial coefficients. So if I'm in the 6th row, I know that each of my coefficients are going to be 6 choose something. And they're going to start with 0. So it'll go 6 choose 0, 6 choose 1, 6 choose 2, 6 choose 3, all the way up to 6 choose 6. And then the A's and B's continue in the same way we did before. A starts with the highest power, so a to the 6th, a to the 5th, a to the 4, cubed, squared, first power, and 0. And B's count up, starting with b to the 0, b to the 1st, b squared, etc. So now just using our calculator, we can determine what each of these coefficients are. So we'll get a to the 6th plus 6 choose 1 is 6, a to the 5b, 6 choose 2 is 15, a to the 4b squared plus 20, a cubed b cubed plus 15, a squared b to the 4 plus 6, ab to the 5th plus b to the 6th. Example 2, find the first 3 terms of the expansion. So even though it's to the 7th power, we're only going to find the first 3 terms, which means I need the coefficient 7 choose 0, 7 choose 1, and 7 choose 2. I would go a to the 7th, a to the 6th, a to the 5th, but remember here our a this time is x. So I'll go x to the 7th, x to the 6th, x to the 5th. Our b in this case is 2y, so I'm going to go 2y to the 0, and then 2y to the 1st, and then 2y squared. So remembering, once I figure out 7 choose 0, 7 choose 1, 7 choose 2, I'm going to have to multiply that by the other coefficients here. And by the way, this squared, my fault, needs to be outside the parentheses. Okay, so this first one we're going to get x to the 7th for our first term. Then we'll have 7 choose 1 times 2, so 14x to the 6th y, plus 7 choose 2 times 4 would be 84x to the 5th y squared. Example 3, find and simplify for the specified term of each expansion. So this is what binomial coefficients are really nice for. So we're going to just jump to the term that contains x to the 6th. Okay, so think about it. We have this being raised to the 8th power. So we want the x term to be raised to the 6th power. What that means is we would need, let's call this, again, a, and this b. We would need our a to be raised to the 6th power if x is going to be raised to the 6th power. So if it starts at 8, it would go a to the 8, a to the 7th, a to the 6th. So really, this problem is asking for the third term. So if we're at the third term, our b will go b to the 0, b to the 1st, b to the 2nd. So we're just going to simplify the term that has this, a to the 6th, b to the 2nd. So we'd be in the 8th row, and we're the third term. So starting with counting at 0, that would be 8 choose 2. And then, like I said, it would be a to the 6th, b to the 2nd. So that would be 8 choose 2 is 28. A is 2x. We're going to need to raise that to the 6th. And b is negative 3y. We'll square that. So combining all our like terms, or multiplying all of our constants, rather, we get our final answer of the term containing x to the 6th. Example 4. We're going to find the 6th term of this 2x minus 3y to the 8th. Okay, so for the 6th term, it's raised to the 8th power, so we're in the 8th row. And the 6th term, remembering that it starts counting out 0, would make us in position 5. Now the 6th term, remember our a is going to start counting with 8. So it's going to go a to the 8, 7, 6, 5, 4, 3. So in the 6th term, our a is going to be raised to the 3rd power. Again, our a here is actually this 2x. Our b is the negative 3y. B then, starting counting at 0, will be raised to the 5th power. As you notice, this bottom number here and this b always match because they both start counting with 0. So now 8 choose 5 is 56. A was 2x. We'll cube that. B was negative 3y. We'll raise that to the 5th. And then we'll be able to quickly find the 6th term. Example 5, just a little bit of quick review before your chapter test of using factorials. This is something you've seen before. If you look at this first one, we know 80 factorial would go 80 times 79 times 78 times 77, etc. 79 would go 79 times 78 times 77, etc. So if we take 80 factorial and divide it by 79 factorial, we're just going to be left with 80. Likewise, if we have 60 factorial, we'll start multiplying by 60, 59, 58, 57, etc. 58 factorial would start by multiplying by 58, etc. So in that case, we would have 60 times 59, which is 3,540. So we can do the same thing with just variables. Think about n plus 1. Okay, so it would start with n plus 1. Then you'd multiply by 1 less than that, which is just n. And 1 less than that would be n minus 1. And 1 less than that would be n minus 2, etc. If we start with n, 1 less than that is n minus 1. 1 less than that is n minus 2, etc. So in this case, we would just be left with n plus 1. Okay, that was lesson 11.8. It can be found in the chapter 15 folder on Schoology.